What isn't the wrong thing?
Okay, so maybe okay, let's see if we can solve that. So let me see, what did you get for P6?
I got 9.8553.
9 point, oh sorry, hold on. So it's not P6 that I should be writing, it's log P6 I should be writing. Give me a minute, let me erase and write. Excuse me. Okay. Okay. So you said it's what? 9 point what?
9.8553.
9.8553. Okay. Okay. All right. Okay. So let me see if we can. Let me launch my own calculator. Let's see if we can quickly get that out. Where's calculator? Okay. Okay. So let me, maybe I should share it in such a way you can see it too. Just give me a minute. Let me reshare. Share entire screen. Okay. So can you see my full screen now?
Yes, sir.
You can see the calculator too, right?
Yes, sir.
Okay, good. Okay, so 9.8553, and then I'll do, because it's already the natural log, so I need the second function. So I'm going to press second function, and this is the second function, the one that has the e raised to power x. So that is going to give me 19,059. So did you notice something? 19,059. That means, and the question was saying how long, how many years will it take the population to become 20,000, right?
Oh, yes, sir.
So I think, I'm not sure, but maybe when we do P7, because P8 was slightly above 20,000. P6 is slightly beneath 20,000. So I'm suspecting that P7 will be just the value that we need. Let me pick that value again. 19,059. I can ignore the decimal parts because it's 0.11 something. 19,059. Okay. So are you ready with the value for P7? Log P7.
Okay. Yes, sir.
Okay. All right. Let's have it.
And 9.9283.
Oh, it still came to 9 point what?
9283.
9283.
Yes, sir.
Okay, got, yeah. Yes. Okay. Hmm. Okay. Anyway, let's leave some room for surprises. Um. So this is P7, and I'm going to say equals to, like that. Okay. So we now want to do, therefore P7 will be what? Antilog of, that will be antilog of all that you just read out. So I'm going to do this. clear entry twice. Let's do the 9.9. 9.9283. Now, I just thought of something now. Do you feel your calculator is faulty? Do you think you need a replacement?
I don't think maybe it's just my mistake.
Okay, okay, okay. But you know where to find all those second function keys and stuff like that, right?
Yes, sir.
Okay. All right. So I'm doing second function again for the natural logarithm. And wow, I think this is the number we're looking for. This is 20,502. So, so the question said, how many years will it take to get to 20,000? And I think this one is slightly above 20,000. Okay, not like P8 that is 22,000. So I think we can go with this if we have to. Look at it again. 20,502. Well, technically, it's even 503 because, oh, okay, no. Let's leave it as 502 because 4 is the number after the decimal point. So that 4 cannot affect 2. So yes, that's fine. So, so did you get that? You
Mhm.
understand, right?
Yeah, I understand you
Okay.
now. Mhm.
All right. Okay. So I don't know if you would like to try again to see if you will get the same answers I got, both for P6 and for P7. You want to try?
Come in, let me remove my coffee.
Okay. All right, I'll wait.
Okay. Yeah, I'm back.
Okay. All
I
right.
need to check now.
All right. So, um, can try P6 out. 9.8553. Second function.
My point. Oh yeah, I got it.
Okay, that's good. Okay. Okay, just for final stuff, let's try P7. 9.9283.
5.9. Yes, I got it.
Okay, excellent. Okay, so let's see. Um okay, let me just minimize. We might still need a calculator at some point in time. If we don't, then that will be till next time we'll need it. Okay, so what do I want to do, sir? Um um so there was some other what do you call them? Questions that you sent me on the mail. Those ones, were you able to try them?
The which ones? Let me see the particular ones.
Okay.
Because
Let
I
me
did.
let me go to that mail the last mail you sent. Hey. Okay, goodness. That's it. All right. Those logarithm questions.
Oh yeah,
This last two from number 8, and I'm not sure. Did I leave any one from number 9 for you to solve, or did we solve all of them?
we did all of them together.
Okay, that's for number 9, right?
We did the 10 together too, and the 11.
Okay, okay, okay.
And
So the
the
only
number
one I
9, I
left for
told
you,
you to do the first one. That.
yeah. Okay, okay. For number 9, you said I should do the first one, or
Mm.
we did. Okay, yes, you said that you had done the 9 at some other time, right?
Yes, sir.
The rest
Yes, sir.
by yourself. Okay. Okay, so this last two for number 8, were you able to do them by yourself?
I only did the yeah, the last one.
The
The last
last
one.
one. Okay. Why did you attempt only the last one? Was it because you felt it was simpler or what?
Yes, sir.
Ah. Sure, you know that this last one is even longer than the third one. The first one is longer than the third one. The only thing that made that third one look longer was the greater than zero,
Yeah, I
which
feel like
really
because
are
we've
just
done like
conditions.
the last
Hmm.
one as example for the like first one.
Oh, oh, I
I just
see.
tried it. I just
Okay.
used the same.
Yeah, yeah, I agree with you. So, but then that third one too. Okay, maybe we
I'll
should do
just
the
try the
third
third
one.
one today before I see.
Okay, you've not tried it, sir. You've not tried it on your own.
Is it the third one?
Yes.
Yeah, it's only the first. I'll just do the third one later today.
Okay, okay, okay. All right. I thought maybe you tried it out and had some challenge. Okay. Um, so how would you rate your skills with quadratic sequences? Would you say that you are more confident about them now?
Yes, sir.
Excellent. All right. Okay. All right. So let's see. Uh, now question 13. I think that's the one that we've not done. Or have you by any means attempted question 13 by yourself?
The 13 is done already, so I've just went through it. Mhm.
Did you say it's done already?
Yeah, because the teacher like gave the answers for the
Oh, really?
yeah.
Okay. Okay. But it's not among what the things you sent to me, right?
Yeah, I think that was just
The
probably
example.
that was screenshotting it.
Okay. Okay. No, it's different. Okay. Okay. No, well, I thought maybe um yeah. Mm. Okay. So, are there any other uh questions, maybe around logarithm that you
Mm,
feel we should work on?
not really.
Because I think these are probably the toughest questions you will see on logarithm.
Currently, we are doing functions.
Okay, yeah, I know you said you okay, people are still doing functions, right?
Yes.
Do you see yourself maybe doing anything around differentiation, integration, stuff like that?
We're just doing injective, surjective, bijective, vertex form, composite function,
Okay.
inverse.
Okay, the different types of function.
Yes.
I see. Hmm. Okay. Okay. Hmm. Okay. All right. So for the topics that you've done so far, in will I say I don't want to say just say algebra in for this academic session. um uh Logarithm, when did you guys do logarithm?
That was last year around that September.
mm, okay. Okay. September. Okay. mm, yeah. And apart from logarithms, uh would you say you are really okay with indices? Because those are the two that usually go together.
Yeah, and this is fine. And
Indices is okay.
we there are parts of this quadratic ones. Algebra, sorry.
Okay.
I want to look for one. Let me just go and check and ask question.
Okay. You want to check that on a web on a site?
Yes,
Okay.
I'll just send them one by one.
All right. You do a screenshot, right?
Yes, sir.
Okay.
Mm. I've sent it. Have you seen it?
Scrolling down now. Or let me zoom out so that I can easily see. Okay, I've seen it. Okay. Okay. So this not exactly under what you are talking about. I think you mentioned quadratic, right?
Yes.
Quadratic sequences.
This is
Or
part
you
of the
just
past
mm,
question. I just
okay, okay. Hmm. Solve the following inequality for x elements of real numbers. Okay. Hmm. Okay, so this particular question that looks this way, let me see, inequalities. Um, inequalities. Okay. Okay, so let me look at the question again. So that x minus 3. Okay, so let me ask, whenever you see those two bars around something, what do those two bars tell you? Do you have an idea?
you know. haven't done inequality.
Sorry, what did you say?
I said I've never done inequality before.
Okay, you guys have not done inequality at all.
Yes, sir.
Really?
Yes, sir.
Okay. Ah, I'm not sure this will be a nice place to introduce it to you from.
I just want to know it so that
Okay,
when you want to do it.
okay, okay. I guess. Um, all right. So maybe I should. So typically, right? They don't uh, look this way, but or maybe I should just explain what these vertical bars mean. So they stand for absolute value of is the absolute value function. So absolute value of something, right? And um, the implication is this: absolute value of maybe an expression like x minus 3, and maybe and of anything generally, right, is the actual value um, of that thing, whether positive or negative. Okay, so what that now means is that, for instance, absolute value of 3, positive 3. Okay, of course, when I say 3, you understand that there's an imaginary plus sign in front of it. So absolute value of positive 3 is still what? Positive 3. While absolute value of negative 3 is what? Positive 3. So it's as if the absolute value is a function only really cares about the size of a certain value. It doesn't really bother with the sign in front of it. So when it's positive, it's the same as that positive. When it's negative, it looks at the positive value that does not have the negative sign on it. So it's about size, okay, not about the sign. That's just um the basic implication of that, of those two um bars there. So in this case now that they said what were we supposed to do again? Solve the following inequality for x element of real numbers. Okay, so how do we solve something like this? We're going to take the bars down so that, and then this inequality will be rewritten. So I'm going to solve this, then I'll now probably take a step back and just basically introduce inequalities. But the good thing about inequalities is this: what you already know about equations, right? What you know about equations, in fact, will give you a solid background of how to deal with inequalities. When I say solid, I mean so solid that there are some things that it looks as if it's only the sign that differentiates it from a normal equation. So of course, from the name inequalities, you can already tell that inequalities are like the opposite of equations. And that's just because of the signs that you use. So for instance, in inequalities, you are using signs like greater than, less than, sometimes greater than or equals to, less than or equals to. So those are usually the signs that you are, you know, dealing with. uh, in inequalities. Uh-huh. But in equations are straight to the point. You come out with an answer and you see x equals 5, x equals 2 over 5, x equals minus 9. It's an exact value. But now that you now have inequalities, inequalities are seldom one value. In fact, they're not even supposed to be one value because I mean, just think about it. What are all the values that can satisfy x less than 5? Let me ask you. What are all the possible numbers that can satisfy that inequality? Can you tell me?
That can satisfy X.
X less than 5.
Mm,
Now, when I say numbers, right, maybe I should be more specific. What are all the integers? You may not be able to name all of them, but just try. Let me see if you understand it. Name all the whole numbers. Another name for integers is whole numbers. Name all the whole numbers that can satisfy x less than 5.
uh, 4,
Thank you. Yes.
3,
Yes.
1/2.
No. Integers.
Oh, integers.
Yes.
That'll
Whole
be
numbers. Strictly whole numbers. Yes.
okay. So 1.
Okay. Why did you skip 2? Because I saw the last number that you mentioned that was a whole number was 3.
Oh
So I
yeah.
expected that you were going like 4,
So
3.
3, 2. Oh yeah.
Mm.
Just because 1 is also no whole number.
Okay. Okay. Oh yeah. Now go ahead. Yes. Okay. All right. Go ahead.
I should keep saying it.
Yeah. Well, you can
Mm.
let me once you start getting into the part that I'm expecting you to say, I can tell you to stop, and we know that there are more that come after that. So go ahead.
Okay. 1.5.
Now, again, 1.5 is not a whole number. So now let me give you the secret about whole numbers. Number one, they are not a fraction does not fall in that line.
Okay. Mm.
Number two, anything that has decimal points does not find itself there. So those are the two conditions. And then of course,
Okay.
yes. So they are
So
strictly whole numbers. You
minus
don't
1.
even to say 1.0, you cannot say 1.0 because
Right.
1.0 is no more an integer. It has come under the um caption or umbrella of real numbers. Okay. So now you stopped at do you want do you think that there is a stop for us at 1? Is 1 the last value that you think would satisfy that inequality?
Mm. I was thinking -1. I don't know if
Good. -1. Well done. So -1, -2. In fact, that's why I said I wanted you to get into, you know, the set of numbers that I was expecting you to say. Then I'll just say, okay, we can just pause it. You can't, no, nobody can name all of them. Why? Because all the way to minus infinity, which is our imaginary largest number in town, you know, minus infinity, that would be all the numbers that can satisfy x less than 5. Okay. So if you are thinking about your number line, you're thinking about number line. You remember those days when you learned about number line. Then anything to the left of a number will satisfy x less than that number. That's just the implication. Now, let's push it further. What if I was interested in only natural numbers? Then you would have just said 4, 3, 2, 1, right?
yes, sir.
Because natural numbers start from 1, not even 0. 0 is out of the league of for natural numbers. If it were real numbers, the set that we're looking at for this guy, this question that I've said solving, then real numbers includes whole numbers, Rational numbers are numbers like fractions. Just take out the word now from rational. It leaves you with ratio, isn't it?
Yes, sir.
So once you remember that word rational, then that means it has to do with ratio. And ratio is anything you can express as something is to something, or something over something. That is a rational number. Now, of course, you can guess real numbers also includes irrational numbers, the numbers that which, those numbers that you cannot write all the decimal points in it. For instance, they told us that pi, or we know conveniently for most of our calculations that pi is what? 3.142, right?
Yes, sir.
But and then they now equally told us that for our calculations we can use 22 over 7 for pi. But do you know that the real value of pi doesn't have an end? It's almost like those recurring decimals that you dealt with when you were looking at um, arithmetic series, where you have 2.33333333 dot, stuff like that. Those are irrational. They're not rational numbers. Why? Because how would you imagine you wanted to convert that kind of number to a fraction? That style where you put one under the decimal point and then you put zeros under the digits that come after the decimal point. You can't solve that kind of one that way. So, except through that our style when we were dealing with arithmetic series and all that. So, technically, irrational numbers too, of course, they contain decimals, but they cannot be expressed as a ratio. Those also fall under real numbers. In fact, real numbers are so embracing. I think the only numbers that don't fall under real numbers are the ones that you call complex numbers or imaginary numbers. Um, so let me just give you an idea of complex numbers. Um, have you ever thought about the square root of -4?
Well,
Mm-hmm.
is that is it possible for minus?
Aha. That's a good question. Is it possible? Because, normally, if they ask us for square root of 4, our mind can fathom that. We can think, okay, it's either +2 or what? -2, isn't it?
Yes, sir.
However, when it comes to -4, you're now wondering, is it -2? Will you say -2 or will you say -2 and +2? And that cannot happen. Why? Because square roots must be identical. You can't have one -2 and the other one +2. No, it will not work. So square root of -4 falls under the league of what? Complex numbers. Now, when we had, I think the first time I heard that word complex numbers, I was like, what? Don't you think these numbers are going to be really hard to work with? Surprisingly, they are not. They are not so difficult. But I don't know. I don't know if it's within people's this thing, scheme of work. But if the need arises, we can look at them separately. But then they are complex numbers, and it doesn't mean that they are difficult. It just means that number one, you can't really represent them on the same, let's say you want to represent them on a plane, right? The way mathematicians reason complex numbers, they reason complex numbers as three-dimensional numbers, all those um, vectors. When you hear vectors in science and all that, they usually conceive the idea of um, complex numbers around that, where you have, you may see something like this 2i plus 3j, something like that. So where the I and the j are simply square root of -1. Okay, so let me not go too far there. But so let me come back to what we're doing now. Real numbers, right? What we have is like this is an inequality. So like I said, let's just solve this. Then I'll back up and just say a few things. Maybe we'll just focus to this class on just inequalities. I'll see if I can do a good job with that. Okay, so um is the guy in the middle that we want to take care of, right? So you know how you usually do opposite of, what do you call it? Opposite of the sign of the one that is closest to the unknown. In this case, that's minus 3. So if I say add, that's the opposite of minus. You know, sometimes it's just the opposite that you are doing. It's each um, um, this thing that you're trying to solve. So we're going to add 3 now. We will not say both sides, but anyway, let's just say add 3 to all terms. So that will leave us with minus 12 plus what? Plus 3. And you can tell what will happen to that guy in the middle. Minus 3 plus 3 is what? 0. Okay. So yeah, just left with what? X. Okay. And 12 plus 3 will be on the right hand side. Because you have to, whatever you do to one, you must do to all. That's the law. Okay. So minus 12 plus 3 is what?
Minus two. That's minus 9.
Good, minus 9. Okay. And of course, we know that 12 plus 3 is 15. So we can simply do this. 15. Okay. All right. So did you get that? You understood what I just did?
Yes, sir.
Okay. But like I said, this is not all there is to inequalities. I'm going to now quickly introduce things, maybe before we go to and I'll see if we have enough time to go to that next question. At least let me see if we can solve two of these questions. Um, um, then anywhere we stop, we'll continue by God's grace in the next class. That will be Thursday. Okay, so let's talk about inequalities, right? So for me to talk about inequalities, I am going to start with an equation. So if you are going to solve this equation, tell me what you would do. 3x plus, let me say 10, okay, equals 30. Okay, sorry, that 3 doesn't look quite like a 3. Yeah, the first one looks better. Not like it's perfect. Equals 37. Okay, so how would you solve this equation?
Did you just bring the 10 over to the 37?
Okay, to the 37, right?
Yeah.
Okay. So if I do that, I'll be left with 3x
Equals to 27.
equals what?
27.
equals 27. Okay. And then what will I now do next?
You divide both sides by 3 and to be
Exactly.
x equals to 9.
Excellent. Divide both sides by 3. And then whatever you divide, you must do it to both sides. Okay. 3 and 27 is what?
9.
9. Correct. Okay. So, see, these skills that you have for equations, you can move them straight into where? Inequalities. But I'm going to give you the rules. There are some rules that you must always remember. But the good thing about it is that the rules are not many. That's what I love about um, inequalities. The rules are not many. You see this thing that you just did now for, excuse me, for this equation, you will do the same thing if instead of, now let me see if I can, if instead of um okay, maybe I should even do something here, so I'll use that as a, okay, no, let's just do it. I'll just do it simply. 3x plus 10 um, less than 37. If this was what you had, you would have done the same thing. And when I say the same thing, I mean exactly the same thing. All you need to do is to do what? Maintain the sign. Don't get carried away and forget that the sign is what? Are you there, goodness?
Yes,
I said don't get carried away and think that the sign is equals to,
yeah, yeah.
whereas it's less
It's
than.
less than it.
Mm. You just have to maintain it. Okay. Now, what are the rules? Let's talk about the rules. So for the demonstration of the first rule, I'm going to put a minus on this. So I want to slightly change things here, change things up a bit. Okay. All right. So let's pretend there was a minus there. If there was a minus there, then that means instead of dividing by 3, I'm dividing by minus 3, right?
Yes, sir.
Okay. And when you divide 27 by minus 3, you get what? Minus
Minus
9
9.
because of the so in this case, x is no more equals to 9, but equals to minus 9. Now, um, you know, okay, no, okay, let me not be ahead of myself because I'm trying to just teach you inequalities. Like this is like a crash course. Think of it like a crash course for inequalities. So first things first, that if you want to like talk about the basics for inequalities, number one, I said every skill you have in what? Equations, solving equations, you can safely transfer it to what? Solving inequalities. Okay. Hope you got that.
Yes, sir.
All right. That's number one. Number two, um, is what I'm about to show you now. So just watch what I'm going to do. We said, you take 10 to the other side and it will become minus 3x uh, uh, less than uh, 37. Okay,
37.
I know I did not write it down in the other one, but let me just write it down in this one. 37 minus 10, which we know is what? On the next line
27.
is 27. Okay, so now watch what is going to happen. We want to divide both sides by what now?
By 3 minus 3.
Thank you, minus 3. In this case, in these questions now, it's even very, very fundamentally important that you take note of the signs, because this is what is going to happen. Anytime you divide, please just remember it like this. Maybe I'll write it out somewhere on this, then I'll now send it to you as I usually do on WhatsApp. Anytime you divide both sides of an inequality, or multiply both sides of an inequality, because it can also be multiply both sides by, once minus sign is involved, please take note, only for multiplication and division. Only for multiplication and division. Anytime that happens, the sign will flip. Okay, so just watch what I'm going to do. Yes, I'll cancel these guys. But when I come to write on the next line, look at what I'm going to do. I'm going to write like this. Instead of less than, the opposite of less than is what? Greater than. Did you get that?
Yes, sir.
So that's rule number 2. Rule number 1 was saying that all your skills from equations can be safely transferred to what? Inequalities. Then rule number 2, that was rule number 1. Rule number 2 says that anytime you multiply or divide by a negative number, the signs will always flip. That means less than will become what? Greater than. Or greater than will become what?
Less than.
Less than. Correct. Okay. So now I believe you got that. So let's go to see something else that I wanted to say. But if you notice, I said let me not be ahead of myself at that point. So what's the idea here that I want to express? Let me just quickly type it so that I don't forget, because I've been promising you I will. And if I keep on, if I move past this now, I am sure I'm going to forget it. And I don't want to forget it. Okay, so here goes. Um, rule 2. Um, or should I start from rule 1? Okay, you can safely, when they talk about transferring skills, you can safely transfer your equation solving skills to solving inequalities. Okay, so this is rule 1. I'll follow it. Oops, sorry. I thought I was going to drag that. It's dragging it. I didn't want to drag it away. I wanted to stretch it. Okay, like that. Okay, okay. So rule 2 says what? The rule 2 is what we just discovered. That rule 2 says that if you multiply or divide both sides by a negative number, the in is, what did I want to do? The in is, there we go. Now, where am I? The inequality. Oops, I didn't spell that correctly. The inequality sign reverses. Okay, so this is rule number two. So let's go and talk about another situation that makes the sign to reverse, and that is going to be rule three. Okay, are you ready for rule three?
Yes, sir.
Rule three says that if um you switch sides of an in a now this thing that I'm about to write now in solving an equation, it doesn't apply. It's unheard of. I'm sure you would have seen when I'm solving, I can switch sides for equations, but for inequality, you switch the sides. If you switch the sides of an inequality, you must reverse the sign. Okay, so let's see that in action. Let's see that in action. Um, where are you? Maybe I should stretch this thing like this. Okay, yes, let's do it like this. Okay, so let's see it in action. Um, so I'm just putting them side by side so you can easily reference it whenever you want, like that. Okay, so for instance, if I had something like this, x, okay, like that, my answer x is greater than -9, right?
Yes, sir.
See what will happen when I switch sides. What I mean by switching sides is this -9 will come to this side where x is, and or just want to rearrange it, another way of that kind of thing that in equations you can do this and get away with it because of course there's nothing to reverse in equations, absolutely nothing. They are not okay. So this, if you try to do that, this is what is going to happen. -9 will come out like this. It gets flipped. Okay. All right. Did you notice that?
Okay, so you move it over to change side.
Yes. Now, do you know that? Let me explain why this thing is so. Let me give you an example. Let's imagine that you wanted to say something like this. 5 is greater than 4, isn't it?
Yes, sir.
Switch sides. Take the 4 to where 5 is. Take the 5 to where 4 is. What would you need to do? Do you notice that you can't leave it as greater than again because you switch sides. So you can only say 4 is less than 5. Did you notice that?
Okay.
Uh-huh. So that's just where it comes from. Okay. Switch sides, you must flip the sign or reverse find the yeah reverse the sign, find the opposite of it. Okay, so let's move on. The next rule, I'm just focusing on the rules because solving the questions on inequalities, like I said, you can safely transfer your equation solving skills to solving inequalities, so it's technically the same thing. So that's why I'm focusing just on the rules. Okay, so the next one says that, and if you notice, the rules, apart from the first one, all of them have to do with reverse, because those are the main thing that you are really looking out for. Okay, here goes. If you multiply or divide both sides by a negative number, the inequality sign reverses. That's number two. If you switch sides of an inequality, you must reverse the sign. The next one, which is the another condition for reversing, is when you have a fraction. Let me give an example. Let's say you have something like this. Um, Let me give an example. I'll put it in its own, in its own section, and then come back here and do this. Okay. Okay. So, sometimes you see equations like this. Um, have you seen equations like this before?
Oh, yes, sir.
Okay. So, I'm just using this to demonstrate. I know what you'll be thinking. You should cross multiply. Okay. Well, um, that's why that is easy to say for an equation. Once you change the sign from equation to inequality, right?
Yes, sir.
Of course, let's say you wanted to solve it apart instead of doing uh, what do you call that thing? Cross multiplication. You can also take the inverse of both sides. What do I mean by that? Take the reciprocal. So that will now leave me with t over 3. Okay. Now, because I made the numerator the denominator and the denominator the numerator. Inequality rule also says I must switch the sign. Okay, you got that? Goodness, you are there, Abby?
Yes, sir.
Okay, good. All right. So, um, you might be saying, do we really need to flip? Yes, you do, because it's more convenient for you to now say multiply both sides by 3, and you will now have t less than 15 over 9 um, times 3. Okay, then you can now do your canceling and all that, and then 3 in itself is 1. Okay, yeah, it's fine. Okay, so we're going to have, therefore, c. Okay, yes, so we're maintaining the sign now after the reversal was only at the top there. Now let me ask you a question. Based on these rules that you've just learned, eh,
Yes, sir.
if I found myself with this scenario, I want you to tell me what will happen. It's not there, oh, but let's pretend that -3 was underneath. What would have happened here?
if it was just like that, like all the question and then it's just -3.
Yes.
Do we need to like break it down?
Well, it's still the same thing. You will still multiply both sides by, instead of 3 now, multiply both sides by 3. You multiply both sides by -3,
Yeah.
right?
Yeah.
Now, but then when you multiply both sides by -3, based on this rule that we just saw, if you multiply or divide both sides by a negative number, the inequality sign reverses. Do you know that the first one that made it to turn from greater than to less than will now reverse again
Okay,
from
to
less
do.
than back to greater than? Did you
Okay.
get that?
Okay. So
Okay. So I just wanted you to, so so it's okay if you did not get the answer, but what I'm just trying to get you to get used to is spotting the places where the rules need to be followed and implementing it immediately. You will see that when you start thinking like that, it's like anytime you see an inequality, your antenna goes up. You know, all of the rules start coming back to you, so that anytime you see opportunities to apply them, you immediately apply them without any apologies. Okay, so are you good?
sorry, I'm not really talking. I'm just having headache. That's why.
Oh, sorry. Oh, yeah. I noticed. I think I noticed it in your voice, but I just felt that, oh, goodness is always calm. So, well, was it hot today? Was the weather hot or something?
No,
Or you didn't sleep well?
it was very windy, and anytime it's windy, I don't know.
Mm-hmm.
It just affects me, and I start having a headache.
Okay. Oh, okay. I'm just thinking of what might really have caused it. I know that if I'm going up against a gust of air, like air is coming at me and all that, and I need to close, like wear a nose mask or something. If I don't, um, I may find that the harsh air, going against my nostrils, inside my nostrils, may affect me and, you know, cause
Yeah, it also
um
happens to me when it's anytime it's sunny
it's oh okay, anytime it's sunny,
and
okay,
anytime it's windy.
it's windy, okay, okay, yeah. All right, sorry about that.
Okay.
I pray for speedy recovery that you get better.
Thank you, sir.
Uh, all right. So, um, okay, so let me just move on to the last scenario. Or that was that not the last one? Okay, I've not typed it out. Let me just type it out. Rule 4. Rule 4 that says, um, um, if you take the reciprocal of both sides of an inequality, if you take the reciprocal of both sides of an inequality, you must, sorry, you must reverse the sign. Yes. And of course, if you take, let me see another way of saying it. If you take the reciprocal of both, if you find the inverse of both sides, if you find the inverse of, take, okay, I think I'll just note it there that, um, um, taking reciprocal is the same thing as um, finding the inverse. Okay, that is numerator becomes the denominator and vice versa or vice versa. Okay, of course, vice versa just means the denominator now becomes the numerator. Okay, so I wanted to save some time back there. All right, so let's see. So these are just the rules. I'll leave it at this. When we have another opportunity to solve more questions with inequalities, we'll see these rules coming out and properly apply them. But for now, let's let's see. Let me see if I can just even do one of these questions before we call it a day. Before my battery shuts down me. Let me see what is left. Sir. Tell me what is left now. Okay.
Mm.
It says 18%. Okay, let's quickly do this. Um, where is it? 4x minus 10 sod 10 sod x. Okay, that's the bracket times 2x plus 5 sod x minus 7. 2x plus 5 sod x minus 7. Okay, so let me say something about a question like this, right? You know, this is normal expansion. The only thing is that they're just throwing number one, sods around. And sods is just nothing more than square root. It's no big deal about them. And I think I've told you that square root is the same thing as raised to power half. So anyhow you need to interpret it. Just important thing is that you just need to know what is really going on. Having said that, the next thing I want to say is that if you find, normally when you see quadratic equations, when you're factorizing quadratic equations, you come up with two brackets that have two numbers in it, either x minus 3 or 2, and then the next one will be 2x plus 2, something like that. You rarely see a situation where you have 2 in one bracket and 3 in the other, like this case. So whenever you see this kind of thing, right, even if the one that contains 2 is on the right hand side, your best bet is to start with that one, the one that has 2. You always start with the one that has 2. The one that has 3 may make your work longer if you start with it. So this is what I mean by starting with it. First things first, I'm going to take 4x and I'm going to multiply 4x by this, multiply 4x by this, and then multiply 4x by this. Okay. And then, of course, don't forget minus this, minus 10, so this. We multiply this and we multiply this and then multiply this. Okay, so let's see how that looks. So 4x times 2x is going to be what? 8x squared. Okay, so if at any point you have any questions, just stop me so that I don't want you to have to answer too much because of the headache. So 8x squared, 4x times 2x is 8x squared. 4x times 5 sod x. So 4 times 5 is 20, right? Okay, so you know um x by itself is like saying x raised to the power 1. And this is x raised to the power of half. That means x times x raised to the power half is the same thing as x raised to the power of 1 and half. Do you agree with that?
Yes, sir.
Okay. So that's 3 over 2, which is like, um, okay, so let me write it this way. Okay, maybe I should do this here. Yes, I knew you were coming. Okay, so x raised to the power of a over b, right? Because I want to do a, oops, sorry, a over b, a over b. X raised to the power of a over b is equal to, the b under is the surd part. So that's going to be b root and then x. The a will be the power. Hmm. Trying my best to write this thing well. Okay, so I can do this or do something like this. A. Hmm. Okay. I've always tried to tell myself, never draw a box until you are sure where the box will end. Okay. Yes. Okay, so that's what I wanted to write. Okay, so that's going to be like 20 because of 4 times 5. Um, so x, because 3 over 2 is going to look something like this. Okay, then the same 4x times 7 is going to be minus 28x. Okay, minus 28x. Oops, that looks messed up. Okay, I don't know why my x is looking like this. I think it's me, the way I'm writing it. Okay, so now let's pick on the other one. minus 10 sod x times 2x. That's going to be minus 20. Okay, can you notice something? This thing is repeating itself. Minus 20, because of the sod x, that's half, x is to the power of half, plus x is to the power of 1 is going to give me the same thing I have there, you know. Uh, Actually, I'm not supposed to write that square root of 2, but I'm writing it because of you. So you have an idea of what I'm doing. But ideally, square root is not written. Square root is just like, it's just like saying something raised to power 1 when it comes to roots. Square root is the smallest root you can have. So I think mathematicians generally don't write it. But I'm writing it because of, oops.